Today we're going to be looking at writing equations in point-slope form. This may be new for some of you, so we're going to look at this. First of all, you need to know what the point-slope form equation looks like. It is right here, and it's also on your notes. You'll see that it says y minus y1 equals m, and then in parentheses x minus x1. As the name says, in point-slope form, we are going to need a point, one ordered pair with an x and y, and we're going to need the slope in order to write it in this form. So when you have a point and the slope, right here on this part of the equation is where you're going to be filling in the y of the ordered pair that you have. You're going to do the opposite of that number because of the subtraction sign. Here in the x1 position, you're going to be taking the x of your ordered pair, and you're going to be doing minus that, so it's going to be opposite that number. And you're going to put the slope where the m is. So you need the slope where the m is, and then there's your xy for the ordered pair, and you just plug in numbers. So here's what the equation looks like before you plug in the numbers. You have the y minus, this is the y1, this is the m, this is the x1. You just plug in the numbers. So when it says y minus, you look here at the y, it's 0, and you just plug it in right there. Here you put the slope. You see that the slope is 5/2, so you plug it in there. And for the x1, you plug in the opposite of 3. You're going to subtract a -3, which is adding 3. So you're just plugging in numbers to those three positions, and you can write an equation in point-slope form. Let's try again. Here's your equation. Again, you're going to fill in the opposite of y here, the slope here, and the opposite of x here. Well, here's the x, here's the y, and there's the slope. So when we plug it into the positions, we have y. We want the opposite of the y, so we're going to say y minus 2 equals m is the slope, so we plug in a -7. Then we have x minus the x, which is x minus 4. So you have the x and y you're plugging in, and the slope you're plugging in, and you have point-slope form. Let's try it again. Again, you're going to be plugging in the y here, the x here, and the slope here. So here's what it looks like. Y minus 1, plug in the slope, which is 2. Then we have x minus 1/2. So you're just plugging in numbers. Now it begins to get a little more complicated. I'll move this a little bit if I can. Move that over. Here they want the equation written in point-slope form, but all we are given are 2 ordered pairs or 2 points. So we do not have the slope. So we need to figure out what the slope is in order to plug it in. Yesterday we worked on the slope formula. y2 minus y1 over x2 over x1. We say subtract the y's on the top and the x's on the bottom. So with what we have up here, I can take the order pairs that I have, and I can plug them in. If I can get my clicker to work. There we go. So to figure out the slope, we're going to subtract the y's on the top. So I'm going to go 4 minus 1. And on the bottom, we're going to subtract the x's, 3 minus 2. Of course, that gives us a slope of 3 over 1, or just a slope of 3. Now that we know the slope is 3, we need to have 1 point. We are given 2 points. So how do we know which one to use? Well, it doesn't matter which one we use, and I'll show you why. Let's first try plugging in the slope and the point to the first point. We're going to use this point, 2, 1, and our slope, and we're going to plug it into our point-slope form. So that would be y minus, our y was 1, so my y minus 1 equals, we plug in the slope next with just 3, and in the parentheses, we're going to sub x minus 2. Here was the 2, here was the 1 that we plugged in. We also need to be able to take this equation and put it into slope-intercept form. Slope-intercept form is when the y is by itself. So basically, I'm looking at this equation saying I want to solve for y. So my first step would be doing the distributive property. So I would have y minus 1 equals 3x minus 6. I have one more step to go. In order to get y by itself, I have to move this negative 1 to the other side by adding 1 to both sides, and I'm going to add it to the like terms over here. That gives me my equation in slope-intercept form. Now let's see what would happen if we would have chose to use the other point, the ordered pair 3, 4 in our point slope form. That would give us y minus 4 equals, the slope is the same, but then x minus 3. So here we've used the order pair 3, 4 instead of 2, 1. Again, to put it in slope-intercept form, we want to solve for y. So I would do the distributive property first. Y minus 4 equals 3x minus 9. I need to get y by itself, so I have to move this negative 4 to the other side by adding 4 to both sides. And look what happens. 3x minus 5. What? Look, they are the same equation. So both this equation and this equation in point slope form represent the same line, the same equation. So if you were to graph that, y-intercept of negative 5 and do a slope of 3 over 1, y-intercept of negative 5, do a slope of 3 over 1, and you've got the line. And look at the two order pairs. 2, 1 would be a part of that line, and 3, 4 would also be a part. Whoops, one more up. 3, 4 would also all be a part of that same line. I didn't draw that very well, but that's okay. Okay, let's look at doing this again. Okay, let's practice again. Again, we are given 2 points, and we want to write it in point slope form. So we need to have the slope. To find the slope, we need to use the slope formula. So we're going to subtract the y's on the top and the x's on the bottom. And we would have 3 minus 6, 2 minus 1, which gives us a negative 3 over 1, or a negative 3. So we now know the slope is negative 3. We're going to use the slope and one of the points and plug it in. Let's use 1, 6. So when we plug that in, that would be y minus 6 equals, we put the slope, negative 3, and in parentheses, we're going to put x minus 1. So we plugged in the 1, 6, and the slope. If we were going to put this in slope-intercept form, we first do the distributive property, which gives us y minus 6 equals negative 3x plus 3. One last step, adding 6 to both sides to the like terms. And we have y equals negative 3x plus 9. As we showed on the last slide, if I used 2, 3 as my point, and I put it into slope-intercept form, I would still have the same equation. So we had the two order pairs 1, 6, and 2, 3. If we find that on our graph, 1, 6, and 2, 3, and we were just to graph this line with a y-intercept of positive 9 and a slope of 1, 2, 3. It's all a part of the same line. The ordered pairs, the slope, everything works out together. Okay, on our next thing that we're going to look at, sometimes instead of them saying, here are your ordered pairs, you will see a table of information. And we have learned that when we have a table, that if this is a vertical table, that the first columns are the x's and the second columns are the y's. So we have here 3 ordered pairs, 3 points. We only need one of the points, but we need the slope, and we're not given the slope. So again, how do we figure out what the slope is? We have to use the slope formula. The slope formula requires 2 points, so you can choose which 2 you want to use. I am going to use this one and this one, and I'm going to subtract the y's on the top. So I did 590 minus 640. And when I subtract the x's on the bottom, they go in the same order. So 30 minus 10. That would give us a negative 50 over 20, or simplified, it would just be a slope of negative 5 halves. That is going to be helpful in graphing. You need to have a rise and a run, but that does equal the same thing as a decimal as negative 2.5, 2.5, 2 and 5 tenths. Okay, now that we have the slope, in order to write it in point slope form, we just need one of the points. Well, there's 3 points to choose from. You can pick any of the 3. So let's just take, which one did I do first? Let's just choose the first one. So here is our x, here is our y, here is our slope. So when we plug it into the equation, we have y minus 640 equals, we plug in the slope, we can either use the fraction or the decimal, and then x minus 10. Okay? Now to write this, back up that up, to put this into slope-intercept form, you might prefer using the decimal if you want to, but we would need to do the distributive property. So that would be y minus 640, and you're going to multiply, so you have a negative 2 and 5 tenths x, and then you have a negative 10 times a negative 2 and 5 tenths x, so that's just going to be a positive 25. Then we add 640 on both sides. And when you do that, you get y equals negative 2.5 x plus 665. There it is in slope-intercept form. On our next example, instead of a table of information, we have a graph. So when we have a graph and we want to write it in point slope form, again, you need a point and you need the slope. When it's a graph, you could use the slope formula and you could subtract the y's on the top and the x's on the bottom. But with the graph, when the graph is going up by ones, you could just count. So let's start here. The rise would be 1, 2, 3, 4. That's a positive 4 for our rise. And a 1, 2, 3, 4, 5. But that's a negative 5 because we're going to the left. So we know our slope is negative 4/5. It would have been the same thing had we used the slope formula. If we subtracted the y's on the top and the x's on the bottom, then we would have had 3 and a negative 6. Oh, sorry about that. 4 and negative 6. Whoopsie. 4 and a negative 6. My goodness, I can't even add today. I'm multiplying instead of adding. Try it one more time. 4 and a negative 5. Woo! There we go. I get the same slope if I will add instead of multiply. Now that we have the slope, we just have to choose one of the points. We have 3, negative 1, and we have negative 2, 3. We can choose one. Doesn't matter which one. Let's say we choose this one. So to write it in point slope form, we say y, and we want to subtract the negative 1. So you're doing the opposite, so we're going to add 1, equals, put in the slope, which is also, if you prefer decimals, is negative 8/10, and then x minus 3. So either one of those, depending on which point that you use. I hope this helps you to write equations in point slope form and to convert them into slope intercept